Okay, we are live. Hello, everyone. Welcome to the Jenkins Online Meetup. Today we have final presentation by Jenkins Google Summer of Code students. Yeah, we will have several demos, so they will present the results of their work. Let me share my screen. Do you see it? Okay. So yeah, I have a short slide deck as always. So just in case you have never participated in a Google Summer of Code, it's a wide initiative. There are thousands of students and hundreds of open source projects participating each year. And in 2018, Jenkins also participates in the project. We have 3 ongoing projects this year. These projects are Code Coverage API by New Renk, then Remoting over Kafka by Vuton, and Simple Pull Request Job Plugin by Abhishek. All these projects reached the last stage, so we have final evaluations starting in GSoC tomorrow. But yeah, all projects reached this state, so we will be presenting the final version. Actually, GSoC for us started in February. The public part with community bonding started in April, so it's almost 5 months ago. And by this time, there were 3 months of coding and also 1 month of community bonding, where teams worked on designs and on getting introduced to the community. So all these stages are passed. We don't expect major changes in the projects, and all projects have been already released as release candidates, 1.0 versions, or at least alpha releases. So today, if you want to ask any questions during the presentation, we have several channels. The recommended channel is Jenkins Google Summer of Code channel in Gitter. It's Jenkins CI/JSoC-SIG. If you want to join the call and ask questions, there is also a participant link, but you can just join the chat and ask questions here. Then we will pass these questions to the students during the presentation. And if you want to ask questions offline, you can just join project chats. For example, there is a chat for Simple Pull Request Job Plugin. There is a chat for Remoting project, and you can find the references to this and other channels on Jenkins.io. So on Jenkins.io projects, there is a GSoC project, and it links all other projects. For example, you can go to Code Coverage API plugin, and here in the bottom you can find all the links. Yeah, here, chat, GitHub repository, etc. So that's all within introductions. We will start from project presentations. So before the call, we agreed that Abhishek will be presenting first, then Vuton, and then Shenyu. So this is the order of presentations. And yeah, let me give a word to Abhishek so that he starts his presentation. Abhishek, are you ready?
Yes. Okay, let me share my screen.
Okay.
Can you see my screen?
Yes, we can.
Okay. So, hi everyone, I am Abhishek Gautam, and I am a final year, now I am a final year student from VNIT, it's the Vishweshwar National Institute of Technology, it's in India. And little bit about me, I am a regular competitive programmer, and I am also interested in game programming and also in automation. That motivated me to participate in GSoC with Jenkins. Okay, so at this point of time, there is no YAML support for defining jobs in Jenkins. So my project was to define a YAML syntax or format so that users will be able to define some jobs and build them. So we have Groovy DSL in Jenkins pipeline, but it is very complicated, and it also complicated with declarative pipeline. So YAML definitions can be used to simplify that. Okay. So there is some prior work. First one is Travis YAML plugin that uses .travis YAML file, which is used by Travis platform to build the repositories. But the thing is that it doesn't make sense to use the settings of a different platform in Jenkins. So, and also it doesn't support external pull requests. And the last commit for this plugin was on 14 November 2016. Okay. Second is CodeShip plugin. It also it converts step.yml and services.yml that is used by CodeShip platform to convert it to scripted pipeline code. It also it has the same problem that it doesn't make sense to use the settings of different platform in Jenkins. And the plugin also has not been released till now. And third is Jenkins Pipeline Builder. It's a external non-Java based tool which is cannot convert it to a Jenkins plugin easily. It does pretty much everything and supports pull requests, and also it sends commit reports to everything. But the problem is that this is not this we cannot convert it to Jenkins plugin easily. Okay, so my project is to create a new plugin which will be used to define jobs in YAML. My mentors are Martin, Kristin, Jeff, Kanark, and Oleg Nanashev. Okay, so the objectives of this project are to define a YAML file so that the job can be configurable using that, and it should interact with Bitbucket server, Bitbucket, GitLab, and all different platforms. And this plugin should also detect the presence of certain types of reports which are present at conventional location and then publish them automatically. And if they are not present at conventional locations, then user should be able to provide the location of the reports. And yeah, to publish build status. Okay, so we decided to build the plugin on the top of multi-branch pipeline. So because it has a nice interface to show builds for pull requests and the branches separately, it can also detect trusted revision in a repository, and it also can publish build status to the repository. So we will get these three things from the multi-branch pipeline. Okay, and then we decided to convert the YAML configuration to declarative pipeline, and in that the steps which will be defined in YAML will be handled by Jenkins configuration as code plugin. Okay. So in coding phase 1, I have implemented git push step and Jenkins YAML. In coding phase 1, we wrote code to use Jenkins file.yml to build the project or repository, and then I implemented a git push step, and build and test performed by user. Okay, so build and test performed by user defined. yeah, we used Jenkins 5 YAML to build the project. Then we had agent configuration in that, and I implemented these three things, which is to harvest reports using JUnit, to harvest reports for find bugs, and archives artifacts section. And I implemented a basic interface so that the YAML configuration can be converted to declarative pipeline. Here's the link of blog post 1 for phase 1. Then in coding phase 2, I implemented step configurators that the so that we can convert steps which are defined in YAML to the declarative pipeline. It had I found two difficulties in that. The JSoC plugin was having difficulty with enums, and it was resolved in PR by JSoC plugin developers. And one more difficulty was it was having difficulty with some classes that are nested with other objects. So this is not resolved till now, as far as I know. And then we defined a proper format so that the Jenkins file.yml can be written and users can use it. Okay. And yeah, I coded the tool property also in agent section of Jenkins YAML file, and I wrote some tests. Then yeah. So about the step code generation, what we do is users will define a step, let's say it's JUnit step like this, and we will pass it to we will parse it and then pass it to JSoC configurator, which will return us a step object. Then we will use snippet generator that is already a part of Jenkins, and that will give us the declarative pipeline code, and we can just place it at the appropriate location, and yeah, we got this thing. In phase 3, I wasn't able to do much work because my college started and the placements was going on. So what I did was I detached the pipeline code generator to extensions so that in future plugin developers can contribute to the generators which I have defined. And I wrote some unit test, and also I done some documentation work. Okay. So one example of YAML file is here. If you can see my screen, this is the dummy project which I am using to test the plugin. In here we have an agent which is defined as any, and we have stages named as first, build, and test stage, and they are calling a script which is present in the repository itself. And then in configuration section we have our archive artifact section. We can give the path to any artifact which we want to archive. Okay. And yeah, if you want to have a look at the YAML examples, then we have them in here. This is the repository we have, and in that we have YAML examples, and yeah, here you can find everything which you need to define any configuration in Jenkins.file.yml. Okay. Next is plugin configuration. Okay, so how should we, when we install the plugin, then how should we use it? So for that we need to create a multi-branch pipeline project, and then in that we need to go down to build configurations, and there is a mode option here. We need to choose by Jenkins file.yml, and then in branch sources, if our project is on GitHub, then we need to add GitHub branch source, and then we can specify owner, credential, and the repository here. And yeah, then we are good to go. Okay, so after we save this configuration, then a build index, the plugin will start a scan to the repository, and it will try to detect all the branches and the pull requests. And yeah, it will automatically start a build for all the newly found branches and the pull request. You can see here I have already started. I have already finished a build. You can see here that the pipeline generated is this. In this we have agent as any, and we have stages: first, build, test, and archive artifact stage. And yeah, you can see the similarity between this YAML file and this declarative pipeline code. And this build was a success. Okay. So yeah, future tasks are to release the 1.0 version of this plugin, and I need to test the plugin for platforms like GitHub, Bitbucket, and GitLab. Actually, I have tested it for GitHub and Bitbucket only, not for GitLab. And I want to include webhook support also in this plugin, so that whenever a pull request is created or a commit is pushed, then a build should be automatically get started. Okay, and yeah, we were thinking that there should be option that only when the pull request will be approved by a trusted user, then only a build should be started. So we have a ticket for that also. Then when a pull request is closed, then we want the workspace to be cleaned up. And then yeah, there is no when like support in Jenkins file.yml for now, which is present in declarative pipeline. So we want to incorporate that also. And we want to have hierarchical report types in this. We have a section called reports in the Jenkins file.yml, but it only works for XML files, and it is just make use of JUnit step. So, but there are more types of reports, so we want to support that also. And then I need to write acceptance test harness test for this plugin. Okay, so here are some reference links. And yeah, thank you. And if there are any questions.
Thanks for the presentation. If you have any questions, pose them in the. There is an echo from somebody. So I had a question about the release. Which version have you been presenting? The last release or the current state of the master branch?
The current state of the master branch.
And when do you plan to release it?
We have a pull request to decide the name of the final name of the plugin and the name of the YAML file. So when we get settled on that, then I will release the 1.0 version.
It will be great to get at least alpha version for now, so that people can try features you have been presenting.
Okay, so yeah, then I guess that I will release a third alpha version in today or tomorrow.
Okay, thank you. So are there any other questions?
Yes, I have a question. This is Martin speaking.
Mm-hmm.
Yes, Martin.
My question is regarding the publishing of other types of reports. What are the next steps to support other types of reports? Like when the plugin development continues, where do we start looking for publishing other types of reports?
What do you mean by where? Can you repeat the question?
In your presentation, you talk about supporting other types of reports and hierarchical support type.
Yes.
Hierarchical reports. So how do we continue that? How does the project continue with that? Where do we start doing that?
Okay. Yeah.
Like in the code or?
I have not researched about that till now. So yeah, I cannot comment on that.
Okay. Thank you, Martin. Does anybody from mentors want to comment regarding the project state? Martin, Christine, Jeff?
Regarding the project state, as Abhishek stated in his presentation in phase 3, the current state of phase 3, we can only do probably alpha release for now. And in the current state in phase 3, the main activity was to detach the snippet, sorry, it was to detach the code generator to extensions.
Mm-hmm.
So the higher level features would be for a future phase of this project. So this project could continue to be developed in the future.
Okay, thank you. So if there is no other, Jeff, do you want to say something?
Sure. So yeah, to align with what was already presented, phase 3, the implementation was a little bit limited due to Abhishek's time. But the project itself had the goal of creating a simple way of building pull requests based on YAML. And I think throughout the course of the project, the general goal was accomplished. We're now left with a lot of interesting work to make this project really a success into the community. But I think we, with Abhishek's work, got a nice piece of code that will get us started with having something that can be easily used for building projects with YAML.
Thank you, Jeff. Okay, there was no other questions in the Gitter chat, so I propose to move to the second presentation. Wutuan will present his work about Jenkins remoting over Kafka. So, Wutuan, are you ready?
Yes, I'm ready. So, yeah, let me share my screen.
Okay.
You can see my screen, right?
Abhishek.
Can see my screen?
Yes, we can.
Okay. So hello everyone. So this is my presentation for the third phase of Google Summer Code. My project is Jenkins remoting over message bus and queue. So the first introduction is I study computer science from Singapore, and working together with me in this project I have Oleg and Sukun as my research mentors. And so Jeff and David have the support from Jeff and David from remoting projects. So let's have an overview of the project. So we have the Jenkins remoting. We use TCP for master and agent communication. So they are exiting the problem with these protocols. First is if the connection or agent fails, we have the build fails and we have to start things again. Another issue is we have the issue with traffic prioritization and multi-agent communication. This impacts Jenkins stability and scalability. So the project is we develop a plugin which use Kafka. We decide to use Kafka to add a fault-tolerant communication layer in Jenkins. So why do we decide to use Kafka? So first is we think about using the traditional message queues such as we have RabbitMQ and ActiveMQ. But then in the community bonding period, we discuss and see that Kafka may have a more suitable features for the project. First is Kafka. It's not a queue. They using the commit log, and also Kafka is more support of data streaming, which RabbitMQ is like that. And also Kafka is said to have a better support and from the development community. So going through the high-level architecture of the plugin, actually, in order to run the plugin, we have multiple components. So as you see from here, we have three main components. We have master side, agent side, and all are connected by Kafka. So previously, master and agent are connecting by direct TCP communication. But with the support of the plugin, all the comments are done through Kafka, and Kafka is we support encryption by SSL. So from the master side, we have the plugin where we have the configuration where you can post and pause of Kafka. And also we have add in the support, use credential plugin to add in support for the configuration where user can store the secret to connect to Kafka. Another important component is the launcher. So the launcher is basically wrapping the classic command transport. So the classic command transport is what we extend from command transport of Jenkins core, remoting core, which create producer and consumer instance to connect to Kafka. And also another important part is the secret manager to ensure the connection security between master and agent. Moving to agent side, we have a custom engine also create a channel which using the classic command transport and a client listener which in charge of the security connection between master and agent also. And agent is bundling removing jar, which we plan to remove it in the future. So so an overview for a set of features we are having now in the plugin. We have global configuration, which supports the credential plugin. We have end-to-end encryption using the SSL feature in Kafka. We have a launcher from master side to launch the agent with Kafka. From the agent side, we have a custom jar to run the agent from CLI. So with all of this setup, the plugin provides a new way for us to run jobs or pipeline with Jenkins over Kafka. So for the next part of my presentation, I will show a live demo of what my plugins have. So my plugin, I set up a ready to fly demo, which use local compose. So the demo will start a pre-config master and agent, and they connect automatically using a Kafka launcher. So to do this, I use Groovy script and configuration as code plugin. So Kafka here is secure and encrypted with SSL. And so there are a few demo jobs so that I can show you how to launch from the agent. So going to the demo, we have so if you want to find information about this demo, you can go to the GitHub repository where did I write the instruction how to run it from the local machine, and it's update every time with the newest version of the plugin. So the demos I use Makefile to run the demo, and we have local compose YAML of configuration as code as well as Ruby script. So okay, so coming back to the demo, we have the Jenkins instance here with the agent automatically connect using Kafka agent. And if you go to the configuration from the global configuration, so we can see the plugin. If you install the plugin, we have the support to config the Kafka connection string here, and also the credential to ensure the security things. Coming back to the agent, so there's a option to launch agents with Kafka here, whether you can choose using SSL or not. Depends. And there are a few demo job here, so I will try to run this job. So this job is basically it's a ping to Google. Then I will try to run it, and the things is if we run this job, it will execute all the commands sort are sent through Kafka, send and receive from Kafka, and we can run it remotely with things. Okay, so so the job is successfully finished. So once again, if you want to reproduce this demo, you can try here. So actually, there are some people already tried this and give me some feedback for the already. So coming back for the presentation, this is quite over replicated. So this is what I just showed you. We have the global Kafka configuration. We have the option to run the agent with Kafka launcher, and also we have so this is not shown in the demo. So whenever you start an agent, you are provided with a connection script to connect your agent as a jar from CLI. And also, this is running of jobs and pipeline with Kafka agent. So this is a summary of the coding phase. So the coding start from May, and we going through 3 phases. So for the first phase is the most important one is we try to create command transport implementation to support Kafka. So in order to do this, we have to make patch in remote thing and Jenkins core to make the thing accessible. So after the things working, then we decide to use Kafka as a final implementation for the project. For the second phase, is more about security, where we support authentication and authorization with Kafka, as well as secret mechanism. There's also an improvement of producer and consumer model to ensure the reliability of what we have in the plugin. And also one important one is this way we release an alpha version, which the first release of the plugin. Moving over, so the third phase is we did important one is the official release 1.0. So it's released under Jenkins main update center, and the current version is already 1.1, which I just released yesterday. So in order to receive the feedback from community for the release, we set up the ready to fly demo in this phase using configuration as code as well as Ruby script. And then we also receive some feedback from the community through Twitter or email. And another thing is test automation as well as documentation, where I update the routing documentation for the plugin implementation. There are bug fixing and cleaning up work in this phase also, and it's a continuous work. So for the future work, so after GSoC, there are some few features on the table. Then one of them may be, for example, chunking capabilities or consumer pooling or agent recovery. So So I'm planning. Yeah, I have a plan to go to present this plugin in Jenkins GSoC. So maybe if some of this feature is done from now until then, it would be great. Yeah. So this is the necessary links for the project. We have GitHub Twitter channel. You can find information about my blog post as well as the demo instruction. Yeah, thank you, and yeah, maybe we can see each other in Jenkins World this year.
Thank you for the presentation. So there were some questions. So there was a question from Jesse about the security side. Is there a way to specify distinct credentials for master and the agent so that credentials can be revoked when they're considered compromised? I should run the question a bit.
Yeah, I'm reading it. Yes. Sorry, I did not understand. I mean, agent machine.
Okay, so the first part is likely to set different credentials for master and for the agent so that you can configure different permissions.
Yeah, but okay, so the problem is so the credential is needed for, I mean, to connect producer and consumer instance to Kafka, and then the producer and consumer setup for both master and agent is the same. So I mean, yeah, I mean, it's not like master and agent connect directly, but they connect to Kafka, and I mean, master need to provide credential to connect to Kafka, and then agent also need to provide credential to connect to Kafka also. And
yeah, sorry.
Yeah.
But they can be different, right?
Yeah, they can be different. Yes, we can set up different user and different secret. Yes, it can be.
Mm-hmm.
Yeah, so yes, we can set up a specific user and password. I mean, username and password for master, and then different username and password for agents. It depends on the system admin to do this.
Mm-hmm. Thank you. There was also a question from Jeff Knurek about performance benchmarks.
Benchmarks, I mean,
Okay, so we can start from this if you prefer.
okay, so for benchmarking, we haven't done anything yet, but yeah, we can create a ticket for this. So which performance benchmark we can consider? I mean, the speed of running jobs or etc.
So there is a number of performance benchmarks located in a remoting project. So it's rather about speed of events delivery, traffic throughput, and also class loading speed and other such things. But we have never launched any benchmarks as a part of this project because the time was limited. And I think it doesn't make much sense to run performance benchmarks, at least until there are some performance tweaks applied. For example, Wutuan has referenced pulling of Kafka listeners. So I think it would be one of the prerequisites for benchmarking.
But I think that might we can create a ticket for this and see how I think. If we have the criteria, yeah.
Why not?
But most of that could be possible even. Yeah, so I think Jesse, yeah, he has a question of mode of attack. I mean the okay. So first is the mode of attack. So the agent can only taken if he knows the secret, and I mean even without the security in Kafka, he needs to know the secret which is part in as the CLI here. It's something as similar to JNLP where he needs to know these secret things. So I'm not sure it's secure enough for you know.
So my proposal would be to spend more time after the main presentations so that we finish the presentations and then we have time to discuss low-level things.
Okay. Yeah, and then
Mhm.
this distributed failure, actually we have a ticket. We have a ticket for the agent recovery. Yeah, so basically this ticket is about if we, yeah, it's a proposed by, I think it's proposed by, yeah, it's proposed by Federico, I mean, last week. So basically it's like when we, I mean, when we have master and agent connection, then the agent disconnect, then we can recovering. Yeah, I think it's possible so that I create this ticket. So because basically we have all the message in Kafka, then if agent can reconnect and connect, I mean agent can reconnect, then it's possible to continue running jobs. But yeah, we haven't implemented it yet for now. Okay.
So are there any other questions? Okay. I guess not for now. So yeah, I'll just briefly summarize the project from my side as mentor of this project, and then we will move on to the next presentation. So yeah, for me, as I said at the previous presentation, it was a pretty complex project because it needed a lot of things to be studied. And yeah, obviously creating production level remoting over Kafka implementation never has been added to the scope of the project. So our idea was to create an operational implementation which would be able to perform tasks, which would be able to which would have some level of stability of failover. And I think that this task has been completely achieved. So we have got an operational implementation. I have an instance where this plugin is running. The setup is up for something like 2 weeks, and I have about 100 jobs happening on agents every day. And so far, so good. There was no issues with the implementation. So I think that from the functional perspective, the project is really fine. And yeah, the most of the questions for improvement would be about performance at large scale installations and stability improvements for edge cases. So if somebody is interested to try the project and to contribute to this service, it would be really interesting. I will be happy to see if Wutuan continues working on this project after GSoC, because the results are really good from my standpoint. Okay, Supun, would you like to say something?
Yeah, sure. During the community bonding period, he did a great research for select that Kafka is the best solution for the project. So, yeah, from the beginning, he did a great commitment. So, and also, yeah, we had a release version, and he did a great job during this GSoC period. And yeah, he's planning to continue his remoting project. So, it's great work so far. So.
Okay, so if we are lucky, we will have some time to work on this project together at Jenkins Vault. Let's see. Okay, so thanks again, Vutuan. Let's continue with the final presentation. So Shenyu will present Code Coverage API plugin and several other projects on the top of it. So are you ready?
Yeah, I'm ready. So I will show my screen. So can you see my screen?
Yes, we can.
Yeah, okay, fine. So this is the third phase evaluation for Jenkins GSoC project. And my name is Shenyu Zheng, and I am working on Jenkins Code Coverage API plugin this year. My mentors are Steven, Supan, Jeff, and Oleg. So about me, I am a third-year student in computer science and technology at Henan University from China, and I like programming and reading some book and philosophy. So regarding this project, there are a lot of plugins which currently implement code coverage. For example, we have Kafka plugin, we have GSoC plugin, we have Clover plugin, and so on. So for those plugins, they are using similar charts and similar content. They all show line coverage of different metrics. So for example, they will show line coverage of package A and line coverage of package B and line coverage of method C, line coverage of method D. So they all show line coverage of different metrics. So it is best if we can have an API plugin which can do the most repeated work for them, like passing reports, like show show coverage result in result page, like process failed conditions and thresholds. Also, it can provide. Also, it will be better if it can provide an easy to implement interface for current existing plugins to implement our plugin, and also for others implement a new plugin. So for now, all plugins support 3 coverage tools. We have embodied coverage. We have embodied support GSoC. Also, we have other plugins as an extension point of Code Coverage API plugin, like Kafka plugin and LLVM cover plugin. Now, our plugin has support those features. We have modernized coverage chart. We have coverage trend image. We have source code navigation. We support a parallel pipeline. We support reports combining, and we have REST API. We also have failed conditions and flexible threshold setting and other small features. So I will show them in live demo. So regarding modernized coverage chart, as you can see, we will show last successful. We will show coverage summary of last successful build in project page. Also, we can see more details in build result. So in the first level result page, we can see coverage summary of different reports, and we can click it to see more details like that. So you can see the different we can see line coverage of different metrics. Also, we can see line coverage of child elements, like packaging. So if we wanted to filter coverage and failed coverage to only show specific coverage, we can use this handler to show the specific coverage. And also, it will pop off the coverage we concerned about. And we also can save the coverage image if we want. Also, we support the coverage trend. As you can see, we will show the coverage trend between builds like that. So, yeah. So we have a model. We improve the coverage result page. Besides that, we also support source code navigation. You can configure it in configuration page like that in there. So you can specify different source file storing level. If you specify it to save last build or save all build, it will save the source files and show it with the coverage information. So we save it and build. So you can see the coverage. You can see the source code coverage in file level. So, for example, in there, you can see the coverage source file with coverage information. All plugin also can be configured by pipeline, and we accept pipeline. We also support a parallel execution like that. You can call our plugin in different branch, and our plugin will merge them into aggregate them and show them. So like that. So save it and build it now. So as you can see, we have specified two. Oh, this is bug. I have changed a lot of code this before, so I will fix them later. Oh, embarrassing. So besides the parallel execution, we also have reports combining. You can add a tag for different report like that, and our plugin will merge them and aggregate into one report. So oh, sorry, I forgot to build it. So, okay. Oh. Oh, sorry, I use a different tag. So the same tag, so that our plugin can match them. I type it wrong. And okay. So the two reports are merged into one. So like that. Also, we have a RESTful API. We provide a REST API for others to recover coverage data. Okay, REST.API JSON. So you can get a coverage result by using with REST API. Also, we can get trend with Also, we can get trend date. Besides that, we also have a flexible coverage, a flexible field condition and thresholds. You can specify the different threshold and in there. For example, if the line coverage is below than 16, it will fail. So this tag is unhealthy tag. So we can save it and build now. So as you can see, this build is failed, and you can see the details. Line coverage in Kafka coverage is lower than 16, so it failed the build. We have other small features, so due to the time limited, I will not show it. So yeah. So in phase 3, wrong type. Also in phase 3 plan, I have mainly done those things support in combining reports within a build, make college API plugin more generic, migrate LLVM college into a new plugin, and polishing code, fixing bugs, writing documents. This is the architecture of my plugin. So we can configure our plugin in build configuration also and pipeline configuration. Our plugin will read these configurations and find the ID paths, then pass those ID paths to coverage processor and start passing process. We will first find the reports and then convert those reports by ID paths passed by coverage publisher and convert it to result. Aggregate those results into coverage result object and press process thresholds, resolve source files, aggregate results in same build, then save the results, add results to action, and return the coverage action to show the coverage result. So how to implement it? Coverage API plugin is very easy to implement. All you need is convert coverage reports to OR standard format, and then also implement an extension point of code coverage API plugin. You can see the examples in Kafka plugin and the LLVM plugin. I will show it quickly for you. So if you implement code coverage tool that we provide abstract layer, it will simple like that. So all you need is one class and one XSL file. So this XSL file will convert reports to our standard format, and this one will let API plugin to find it and convert it with convert reports with XSL file. So it are very simple. But if you also you can implement a plugin that we do not provide an abstract layer like LLVM plugin. So if you implement a plugin that we didn't implement a coverage tool that we didn't provide register coverage elements like that, and also specify its order. Then implement a document converter which convert the report files to a document object. For example, in there we convert JSON report files to our document object. Also, you need to write a very simple parser for that by using the code we provide in college parser class. So it is very simple like that. Yeah. So this is all the things we need to do if we want to implement our plugin. So in the future, I plan to implement more college tools and make the UI extensible. For now, it is only only allows other plugins to show the specific college information. But in some college tool, they have complex and other information want to show. So we will make the UI extensible so that others can add more chat for our plugin. And also, I will improve performance. For now, it will passing XML file to document and read the document in memory. So it is a memory cost. I plan to replace it to sex parsing in the future, and also for JSON parsing, I plan to replace it to stream parsing. There are some useful links. You can see more information in our project page. Okay. I see more information in our project page. Yeah. So thank you. Okay.
Yeah, thanks for the presentation. So are there any questions? Oh, yeah, we can start from Jesse's question, I guess.
Yeah, for the last question, it didn't pass in. So we have converted this JSON file into a document object, and we actually pass in document object. We fast convert we fast read the JSON file into JSON object and convert it to document, and then passing document. So it is yeah. And about true false. Or you say the branch. We have a condition no coverage. It is like branch. Yeah, we have branch data from Kafka. Yeah.
Yeah. So which types of reports do you support now in the plugin?
We support GSoC, Kafka, and LLVM coverage.
Mm-hmm.
Yeah. Oh, about Martin's question, I didn't see it. Okay, I have shown it in the demo. If you want to, if your report doesn't not have say packages, you need to register it and let it register it like that. Sorry, you need to need to register it and specify it in parser. Yeah, I didn't use native. Why would you not just use? Oh, I use native report format. All them is converted to the same format. All other coverage reports is converted to the same format. So yeah. So we can. This is why the parser is like that. All them is the same format. So I will write a developer document for it after meeting to display it. Yeah.
Yeah, so there are some data entries which are shared between formats, but Shenyu has also added some flexibility so that you can report custom data points which are specific to particular languages. So, for example, for C++ and Java, you may have different entries in coverage reports.
Yeah. Okay, fine. I will write some abstract layer for different languages.
I thought you already have it.
Yeah, we have Java abstract layer, but didn't support other languages. So you can say in there. We support Java in Java parser, and also support also register element in there. So we have an abstract layer for Java language, but didn't have it for other languages.
Right. But it's pretty well aligned to what other code coverage plugins do now. So I've been converting VHDL and Verilog reports to Java code coverage for years, and it worked. Yeah, but of course there could be some optimizations for other languages.
So can you repeat your question? I'm not here.
Yeah, my point was that even if there is only Java structure offered in the plugin now, for many use cases, it should be enough for use cases which are way outside the Java world if needed.
Oh, yeah. Okay. Because they have different coverage element. For example, for Java have packages, have group, have method. But for LLVM, we didn't have. It is different from Java. So, we need to specify. We need to pass them according to its type. For example, we need to pass if the element is line, and also we need to set a relative path if the element is file, and to do those specific actions. They have different coverage elements, so we should specify the actions for different cases. Yeah. Is per language. LLV is per language. I think LLVM coverage is for a series of language like C, C++, and Object or Swift. So yeah.
Yeah. Okay, so what we could do is we could continue the discussion after the broadcast. So if anybody wants to discuss particular topics in detail, we can just stay on the call. I'm not sure whether it needs to be recorded in the Jenkins Online Meetup, but yeah, we have some slots. So for example, JC, if you want to join, you can just jump into the call and we continue the discussion. Okay, so thanks for your presentations, Abhishek, Wutuan, and Shinyu. Yeah, and thanks a lot for your projects. It's nice to see that all projects have reached the stage to when they can be used by Jenkins community. And yeah, I hope that there will be some work around this project continuing in the next phases. So yeah, thanks a lot for the work you did. And of course, also thanks to all mentors who help with these projects, and to all other contributors who were participating in meetings and providing feedback in the mailing lists. It really helped to get these projects over the fence. Okay, I guess that's it for today. So I will stop the broadcast. Thanks to everybody who was watching this YouTube channel. And yeah, if you're interested to get more information about the projects, please go to the Jenkins.io website, and you can find all contacts and all project links there, so that you can try the projects on your own. Okay, that's it. Thank you.